Okay, so we just finished dealing with radicals, and now we're dealing with rational. Why are those two put together? Because they're the ones that are high maintenance, right? All the rest, it's just domain range. You just look at it and whatever. Radical functions, oh, that stupid thing under the radical sign has to be positive all the time, so you got to deal with this. What is the pain in the butt with rational functions is that bottom can't equal 0, okay? Now, the good news is we have done this to death. So most of this will be entirely review, okay? There's only one new part, and it's not that hard. Now, rational functions, we have to watch when there's an x in the bottom, okay? Now, by definition, it cannot be a rational function unless there is an x in the bottom, okay? So rational says there's an x in the bottom, not a 5. Okay, I know we think rational, that's a fraction. So 2/3 x, that's not a rational function. Okay, 2 over 3x would be a rational function. Okay, so if you had 2 over 3x, that's not rational. But 2 over 3x, that's rational. Okay, and why? Well, because there's an x on the bottom of the second one. Okay, so rational functions are, pain because I got to find all asymptotes, all these asymptotes, and drawing lines all over my calculator, and this stuff's so confusing. Okay, so let's just deal with x in the bottom now. We dealt with x under square root signs. Let's deal with them on the bottom. Now, when you have x's on the bottom, you will run into discontinuity. Okay? In other words, you have to pick up your pencil to draw the graph. Okay? So if you were drawing the graph, you would actually have to pick up your pencil to keep going with it. Okay? So to be continuous means you don't have to pick up your pencil. So this is you have to pick up pencil to draw. Again, that's the simplest definition as I can give you. But if you're drawing it and you got to pick it up, it is discontinuous. And I can guarantee you that if it's a rational function, it will be discontinuous. Now, there are two types of discontinuities. And that's when you have an infinite discontinuity, which we have called a vertical asymptote. Yep. You're picking up your pencil to draw that other point. Yeah, exactly. So you do have to pick up your pencil to draw that, though. Yeah, if you go left and right and you get the same, then it's continuous, right? And the point of discontinuity is a hole in the graph, okay? Now, the simplest way to show this, if you had 1 over x plus 2, this will give you an asymptote at -2. Okay? So if I was to draw this, I would have an asymptote at -2. Okay? Now when would I have a hole in the graph? Well, I would have a hole in the graph if I had x plus 2 times x plus 3 over x plus 2. Now, at first glance, if you just look to the bottoms, you go, what? That doesn't make sense. Now x plus 2, they're both x plus 2's in the bottom. Why is that one a hole, and why is the other one an asymptote? Because when this and this cancel, I would be left with x plus 3, where x cannot equal -2. Okay? Now, x plus 3 is a nice little graph. It's, goes right through 3. Right, go right through 3. The only problem is I'm not allowed to use -2. So what it would look like is, because if -2 is like there would actually be a hole in the graph, and it'll go like this. Okay, so to be able to draw that graph, I actually have to pick up my pencil, put it back down, and draw it again. I am not allowed to draw through -2. Okay? Now, when I go through these notes, I'm like, oh man, I got a lot of writing and all this stuff. How can I make it really simple? And hopefully you're doing that for your study sheets, and this would be a good little thing. Always have little examples if you can, because word definitions aren't very helpful in math. Right? To have a picture of, well, what would give that? Like, what would even make that? That's the kind of stuff you need to know for a diploma. They're not going to ask you a definition. Okay? They will ask you to apply that definition. So, we have done these before. This is review. And that's good. Okay? So, let's go all the way to page 460. Okay. Now I know that upsets some of you that we are not using all those pages. Yet you paid for the whole book. So if you like, on the weekend, go fill it in. Go nuts. Okay? Now, like I said, vertical asymptotes, right? We've done those. So if it's 1 over x plus 2 times x plus 3, x cannot equal -2 and -3. So then I would draw asymptotes there, right? Easy. Now the new thing, unless of course you're in calculus, is horizontal asymptotes. Now horizontal asymptotes, for us, they're going to be very easy. Unless you don't even know how to find horizontal asymptotes, then they're not. But horizontal asymptotes have been showing up for you guys for years, right? This is the first time we're actually going to talk about them, of course, unless you've been in calculus. Because there are times that it will not go through, or it will end up there if you went to infinity. Now, the rules that you need to know are extremely simple, yet important. Okay? So here are the rules of horizontal asymptotes. Now everybody knows what I'm talking about by horizontal asymptotes. It looks like that. Okay? It actually goes horizontally. And that would be like at y equals 5, or y equals a half, or y equals 0. Okay? So these are y equals. When you do, these are x equals, right? Okay, that's the equation of a vertical asymptote. The equation of a horizontal will be y equals. Now here are the rules. Okay, rule number 1. If the degree is of the numerator is less than the denominator, the asymptote will be at y equals 0. Okay? So, if the degree of the top is less than the degree of the bottom, y equals 0 will be the horizontal asymptotes. Okay? The trick that I always used to find horizontal asymptotes is kind of like limits, is I put infinity in there for x. What's 3 divided by infinity? It's 0. Okay? Try 3 divided by a billion. 0.00000, okay, it just keeps on. It's pretty well zero, guys. Now, that's how you can always look at it. And the way that I do it, if I just can give you an example of this one, if say you had, 3x plus 6 over 2x squared plus 5x plus 2, all you do is you pick the number with the biggest degree on the top, and the biggest degree in the bottom would be these two. So I'm not looking at the 5x of the second one, but do you see how the degree of the top is less than the degree of the bottom? Therefore, that thing, if I put infinity in for x, 3 times infinity divided by 2 times infinity squared, the bottom wins. The bottom has more division power. It'll make it equal 0. Whenever your bottom is infinity, it will equal 0. The horizontal asymptote. Okay? Now, what happens if your degree is equal? So, if the degree of the top, degree of bottom, it equals to the leading coefficients. Okay? So, see how you have 2x over 1x plus 1? What you do is you circle these. You go, hey, they're the same degree. So this is the same thing as 2x over 1x. Now, I'm not looking at the rest of the equation. Those would cancel. Your horizontal asymptote would equal 2. So you'll see there will be a dotted line at 2. Now, the third scenario is when the degree on the top is bigger than the degree in the bottom. Okay? We haven't dealt with that. So do you see these are 3 sets of rules that in a week you might forget? Okay? If you do forget, always put infinity in there if you can and see what the answer would be. And by infinity is like 10 billion. Put 10 billion in for x, it'll actually give you the horizontal asymptote. Okay? Anyway, here if we have degree greater than degree in the denominator, it has no horizontal asymptote. Now this is really confusing the way it sounds. It should have both of these underlined, no horizontal asymptote. There will be an asymptote. It's what we call oblique or slanted. So there will not be a horizontal one. It will be oblique, which is slanted. Okay? Now, in calculus, did you guys do those? No? Okay. And I'm not going to go into detail how to find those because it's not part of the curriculum. All you have to tell me is what the horizontal asymptote is, and if there isn't, you say no horizontal asymptote. Okay? Now, here's the thing that you need to know about horizontal asymptotes. Okay? Oops, I guess it would be all of them. Now, this is kind of maybe non-intuitive, but the graph can go through horizontal asymptotes. Okay? Again, it's another thing that calculus I don't think dealt with. Okay? So, graphs can go through horizontal asymptotes. They will never go through vertical. Okay? See, the point doesn't actually exist when it's a vertical. That point doesn't exist. Now, the first question I would ask if I were you guys is like, what the heck is it? Why is it a horizontal asymptote then if it can be it? That doesn't even make sense. All I've ever known about asymptotes gets really, 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 really close and it never kind of, that's that imaginary line. A horizontal asymptote is more telling you where the graph will go and level off if it went forever. Okay? So I'm going to show you in the next one, which is good because there's a couple later, that if you graph the next one, it does. The actual graph goes through the horizontal asymptote. Okay? But it is allowed. Now, it says algebraically determine the equations of the asymptotes of the graph of the function. Here it is. Verify using your graphing calculator. Now, the first thing you always want to do is factor. Okay? If you've been in calculus, you probably have been factored to death by now. Okay? And if when we do factoring in here and you think they're hard, like some of the calculus ones take a whole page, right? And after a whole page, you probably made 3 mistakes. Okay? That's one thing when you teach this stuff, you always do it beforehand, right? Or you make all these mistakes like 1 plus 1 is 3 and the whole thing, right? So these are really, really easy when you start to compare. Now, we want to factor the top, we want to factor the bottom. The top one's nice because it's two things add to 1, multiply to -6, and you get x plus 3, x minus 2. Okay, that one's nice. This one, not so nice. We have to look for two things that add to -1 and multiply to -6. Okay, and those would be -3 and 2. So then you go 2x squared minus 3x plus 2x minus 3. Okay, then I can put brackets around this one. I can take out an x, leave me with x, 2x, minus 3. This one I can take out a 1, leave me with 2x minus 3. So then therefore this becomes, I'm just going to rewrite the whole thing. This would be x plus 3 over x minus 2 all over 2x minus 3 times x plus 1. Okay, so this is factored. That's what it would look like. Okay. X plus 3 times x minus 2 over 2x minus 3x plus 1. So, let's do vertical first. So how do you find the vertical asymptotes? Right. Find when the bottom equals 0. Okay? So we want to find when the numerator equals 0. So the numerator, I have 2x minus 3 and x plus 1. So denominator, sorry. Okay, and the denominator equals 0. So when does that happen? Three over 2 and -1. Now, how do you find the horizontal asymptote? Right, so you look at the degrees of the original. So you go here and you look at that one, you look at that one. So the winner of the top divided by the winner of the bottom. Okay, so the highest degree, just write them over each other. And it should even make sense at this point. You see how the x squares would cancel? Right, so the x squares would cancel, leaving you with a horizontal asymptote of 1/2. Right? Okay, now we need to graph this. And we have to see what it looks like in your calculator. because your calculator is different probably than the person beside you. Okay? I know you guys think you all have the same calculators, but half of you have one type, half of you have another, and you have to know your calculator when you go in. So do you have an 83 plus, or do you have an 84? They do behave differently. Yeah, that one's going to behave way differently. Okay, so what you want to do is put it correctly into the graphing calculator. I seem to somehow manage to put it in wrong almost every time I do it. It's a gift I have, and I'm trying to brag, but... So then usually I have to put it in, and then I go, what? That doesn't make sense. And now, one thing you don't want to do is put it in your calculator wrong, and then change your entire answer now, so it looks like that. Wrong answer. Now, then let's hit zoom 6, so we're all looking at the same beast here. Okay? Now, if you're doing an 84, you will not get those straight up and down lines. Now, that's the calculator you're taking into the diploma. So, you have to understand how it works. Okay? Because that's why you're using it all 3 years. And it is good if you've had the same calculator for 3 years, because you sure do not want to borrow someone's 83 plus. And you're like, what? Whoa, this is weird. I don't know what's going on here. Okay? So the 84 just likes to draw the graph. It doesn't have these straight up and down lines here. Okay, this looks like a really bad heart rate, right? Now, so this graph, if we just try to draw it kind of roughly, let's draw one together. So ours, which is mine. Okay? Now, what's the first thing that I should draw in? The asymptotes. I have asymptotes at -1. I have asymptotes at 3/2. And I have a horizontal at 1/2. Okay? Now, the graph goes like this. Okay, it went something like this. And then, now this one, if you go, oh, it actually does this. I'm exaggerating a bit, but it does that. It actually goes to the asymptote, does a little jump, and then levels off at the asymptote. So when it goes to infinity, it actually reaches 1/2. Now, it does it nicely on the left side. But the right side is the point where you go, whoa, 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 I thought, no, this can't be an asymptote. Asymptote means you cannot go through. Okay? We've always learned that. And for vertical, it's true. It can never go through the asymptote. But it can for horizontal. Okay? That's just how it works. It's math. Okay? And you know, students are asking, like, how do you even find the maximum points and the minimum points? Well, if you hit your trace button, and if you get your, do you see where the spider is? He's right here. See him? If you can actually go second trace, which I already have been. We're going to do 4. I want to find the maximum. So I hit enter. And if I go over here and I hit enter, enter. So that's the maximum when y equals 0.56. Well, 0.5 is supposed to be my asymptote. So I can show right there I went above it. Yep.
So on a 84 plus, the spider is going below, how do we move it?
You just keep cruising. Yeah, and that's how you actually, on the 84, if it's jumping around, that's discontinuous. There has to have been asymptotes there. Okay, so if you're taking your calculator into the exam and you do not know your calculator well and know its personality, okay, then, you know, I have students all the time going, well, it's not quite giving me the maximum there. And I said, yeah, it's, you know, 0. Or it'll be 3.999999999. That's 4. Okay? So sometimes your calculator is very specific, and sometimes the farther away you get to your maxes, they do that. If you're really close to both sides of it, it actually does a better job. Right? But that's the stuff you want to figure out before you go into the diploma. You don't want to be in there going, okay, let's do some graphing. How do we do that again? I think that was like the Y button. I remember people talking about the Y button. Okay? And if you keep going with the trace button, you'll see, oh, I'm not on the graph. Okay? You'll see how it is getting closer and closer to 0.5 again. See how it's going down. Okay? So, the moral of the story is make sure you understand that it can go through the. So know your rules for horizontal asymptotes. I think you should know your vertical ones quite well. Doesn't mean you shouldn't write them down in your study sheet, but that's all we really learned today, if you think about it. It's horizontal asymptotes. So let's do 1, 2, and 4 to 9. It's good, right? And you guys are all done in calculus, right? So, exactly. Right. So when you find that what the limit equals, that's actually an asymptote. I mean, you have to